This is Algebra 2 with trig, 1D.1b. We are going to solve system of equations algebraically. In Algebra 1, you would have solved linear systems by graphing, by substitution, and also by elimination. So we're going to talk about this one using elimination. So we're going to solve the linear system using elimination. Elimination is the idea of getting rid of one of the x value, or one of the variables. It might be the x. It doesn't matter. Sometimes a problem could be set up so it's easier to get rid of one of the variables rather than the other. In this case, I notice that I have 1x, and here I have 3x. If I were to add these two together, it would currently add up to 4, but I want it to add up to 0. I want to get rid of my x's. It's your choice which variables you want to get rid of. I'm choosing to get rid of the x's. So I'm going to multiply this first equation by -3 to help me get rid of my x values. So -3 times x is -3x. -3 times 4y is -12y. -3 times 1 is -3. So I have changed my equation. I've multiplied everything by 3. So now I notice that 3 for the x and -3 for the x are going to add together to become 0 x's. So I've eliminated the x's. And that's going to give me -10y, and that's going to give me -15. And I'm solving for y. So I divide by my -10. And I see that 5 goes into 15 3 times, and 5 goes into 10 twice. Of course, it's positive because these were both negative. So I have my y value of 3/2, or 1.5. Now I need to figure out what my x value is going to be. So what do you think we might do to figure out our x value? You can plug the 3/2 into either one of the equations, your choice. So we have x plus 4 times 3/2. I'm choosing to plug it into the top one. It just looks a little bit simpler to me. Now, how do I multiply the 4 times 3/2 together? How do we do that math without a calculator? We get our value of 1 for our denominator. When we're multiplying, we don't need to make them the same, but you might want to say that 4 times 3 and 1 times 2. 4 times 3 is 12, 1 times 2 is 2. If you can do that all in one step to understand that that's a value of 6, and then we subtract the 6 across, and we have an x of -5. Now, we can just for a moment, we can test it in the other one. If you really want to know if you've done it right, you could test it in the other equation. You don't need to do this. But just to show you real quick, this becomes 6/2, because 2 times 3 makes 6. And of course, that can be reduced down to 3, and subtract the 3 across to make 15, and divide by the 3 to make -5. These, you should get the same answer. It doesn't matter which one you plug it into. You don't need to plug it into both, but you do need to plug it into one of them. So my answer is -5, 3/2. So that was a process of using elimination, and we even checked it. We plugged our value into both equations to see if we got the same answer twice. And that is used when you have two linear equations. It's a great way. Now, when we come down here, what two types of equations do we have? What type of equation is this one on top? It's a circle. What type of equation is the one below it? It's a line. It's linear. So how many times can a line and a circle cross? They could cross twice. They could cross once. Or they could cross 0 times. So any of those are possibilities. So let's see what happens here with this one. So elimination doesn't work as well when you have squares and not squares. So we're going to use substitution. In substitution, you need one of your variables isolated, one of your variables all by itself. So it really helps in this case that this is just y equals 6. It's as simple as it gets. So x squared plus 6 minus 3 squared equals 25. So I plugged in my 6 in for my y. 6 minus 3 gave me 3. And then I'm going to square that value. And subtract it across. This is x squared equals 16. So what do I need to do if I have x squared equals 16? I need to take the square root of both sides. And what answer do I get? You get a plus and a minus of 4. Does that make sense? Could you have two different x's? Yeah, if you're going to have two different locations where the graph is crossing at, you're going to have an x value over here, and you're going to have an x value over here. It could possibly be a positive 4 and a negative 4. So now what I'm going to do is take one of those and plug it back in. Now this is kind of silly because you're allowed to plug it into either equation. And if I choose to plug it into the bottom one, do I have anywhere to put in my negative 4 or positive 4? No, there's no x's down there. My answer is 6. My y is 6. End of story. No need to do a calculation. Now let me show you what happens if you do a calculation. Gets a little scary. So if you put your 4 in there, so I plug my 4. Even if I plug negative 4 and I square it, I'm still going to get 16. So it's the same for either number. Here, if I square this, I do not get y squared plus 9. That's not how that works. So you need to be sure that you set this up correctly. You need to be sure to write that twice. Write your binomial 2 times. Here we're going to get y squared. I don't need my parentheses anymore. So y times y, when I FOIL this together, negative 3 and negative 3 gives me negative 6. 3 and 3 gives me 9. So I multiplied, or I squared, this binomial. So it looks like I have y squared minus 6y. This becomes 25. And I have 25. Move my 25 over to the same side of the equal sign. What am I going to do with that? I can pull out, you don't want the 6y on the right side because it's a b value. We're just going to factor out. So I get y equals 0 and I get y equals 6. Well, we knew y was 6. And if y was 0, when you plug it into the other equation, does 0 equal 6? It doesn't balance with that. 0 doesn't equal 6. But does 6 equal 6? Sure it does. So that's why we can eliminate that. It's like an extraneous solution. It's a solution that we did all our math correctly for, but it's not an answer to our problem. So we've got 6 and we have 0. There was another method that I could have used here. I got carried away. Another method we could have used, 4 squared plus y minus 3 squared equals 25. I could have subtracted the 16 across. Y minus 3 squared equals 9. I didn't need to square my binomial. I got a little carried away. I did, and it worked out just fine. But you didn't have to. You could have used square roots. And then I'm going to add my 3 across. So I get y equals 3 plus 3. And I get y equals 3 minus 3. And again, I get 0 and 6, just like we did. And when I plug the 6 into the other equation, I see that it works. So that's a possible solution. When I plug my 0 into the other equation, it doesn't work. So that's a good way to know you can eliminate that as a possible option. So either way, those are our solutions. Let's come on over to number 3. What do you think about 3? Why don't you pause the video, give this one a try. How are you going to set it up? It's a lot smoother than this first one. First of all, what are the two shapes we have? What's this first shape called? It's a parabola. What's the second shape called? It's a line. So how many times can a parabola and a line cross? Could cross twice. Could cross once. Could cross 0 times. So you could get 2 answers, you could get 1 answer, you could get no answers. You'd have some sort of fact that showed that there's no real solution. So you go ahead and think about this, pause the video, then we'll talk you through it. So we should talk about this parabola real quick. I did imply that the parabola opened upwards, but if this is y squared, this parabola is actually opening up sideways. Okay, you've never had a parabola open up sideways before. We'll do that perhaps second semester, but doesn't matter, we can still solve it. Okay, so graphing it's going to be a challenge. It tricked me. I just saw the square and ran with it, but it's a parabola on its side actually. But I have my y value by itself, so I'm going to take my 2x and square it. Now I have one equation with one unknown variable. That I can solve for. So I'm going to square my 2x. That is 2x times 2x. I need to square that. And 2x times 2x gives me 4x squared. So here I have two different types of x's. I could divide by 4, but you cannot divide by the x. Don't divide by the x because you'll lose a factor. So let's just move the 8x to the other side. Whenever you have a b value, you need to move it over with your x squared. Now here, I have a factor, a GCF that I can pull out. And I do use my zero product property. And I get my two answers. It's going to happen at 0 and it's going to happen at 2. So I can choose which one I want to plug it into. When x is 0, I get 0. When x is 2, I get 4 for y. So 0, 0 is the solution, and 2, 4 is a solution. Those are my two solutions. All right, let's come on down here to this one. What two shapes do we have? We have a circle because the x squared and the y is squared. And what's this one? This is a line because it's x to the first power. That is a circle, and that's a line. So we're going to do the same thing. Do we have a variable isolated? Yes, we do. So we're going to use that by plugging it into the other equation. And to do that, I'm going to need to write that binomial 2 times. And then I'm going to FOIL this together, and I get 9x squared. I get negative 30x. I get another negative 30x. And then I get 100. That looks pretty disgusting. Looks crazy looking. What do we do from here? You've got to make decisions. The math is simple. Add together the like terms. You got some negative 30s to add together. You got some x squareds to add together. So we have 10x squared. We have negative 60x. We can move the 10 across to get 90. Okay, so now we have a quadratic. How do you want to solve this quadratic? Got to make some choices. What are your options? Can you factor this? That looks intimidating. Do you want to complete the square? That's possible, but still intimidating. You want to use quadratic formula? That might work, but you have some pretty big numbers. We see that there's a multiple of 10 in all of these. So because we're solving, we can actually divide by the 10. We don't need the 10 anymore. I know, boy, that makes me feel so much better. So much easier to deal with. Now I can simply factor this one as what multiplies to be 9 and adds to be negative 6. So I get one answer. Here, let me take my time. Let me do it all out there. It would be x minus 3 equals 0. So x is going to equal 3. I have one answer, one x value. Is it possible for a circle and a line to cross at only one spot? Sure it is. So it seems to be what's happening. Now I can take that and plug it back into my suggestion would be to plug it into your linear equation. Because otherwise you plug it into your circle and you'll get two answers and you got to test one of those to see which one's right and wrong. So plug it into your linear and you don't have that issue. So we'll have y equals negative 3 times 3 plus 10, y equals negative 9 plus 10, y equals 1. So it looks like 3 comma 1 is our solution. And our last question over here, what do you suggest we do? What do you see? What don't you see? What do you need? You've got to isolate one of the variables. Okay? We need to move the 3x over. And now you have y equals 3x plus 6. You need to know what y equals, or at least the x. So now we're going to have 8x plus 3x plus 6, and that is squared. Plus 24 equals 0. Only thing I see I can do here is to say 3x plus 6 and 3x plus 6. You've got to square that binomial, and you cannot do it by distributing in. You've got to write it twice. So we FOIL this together. We get some big numbers. Plus 18x plus 18x. 6 and 6 is 36. It only looks like I have one set of x squareds. This here looks like 36x. 36x plus 8 more x's sounds like it gives me 44x. That's 50, and 10 more is 60. That doesn't look too nice. How do you think we might work with this quadratic? Factoring looks a little scary.
Maybe finding C or whatever.
Trying to complete the square?
Yeah.
The problem with completing the square is I have an a value, and if I factor that a value out, I've got my 44, and 44 is not divisible by 9, so you get a fraction. Probably don't want to go that route. So negative b plus or minus the square root of b squared minus 4ac all over 2 times a. That's pretty ugly. X equals negative 44 plus or minus 44 squared minus 4 times 9 times 60 gives me a negative value inside. B squared minus 4AC. So I have a negative value inside my square root. What does that tell me? You're going to have an I. You're going to have an imaginary solution. You're not going to have a real solution. No real solution. This is a this is a little complicated looking thing, but It's a parabola on its side. And this is a linear equation. So they're not going to cross together at all. So they do not intersect, and the way we found that is when we tried to figure out what x was, we had no real solution using our knowledge from before. We won't pretend that we're working with I. We're done. They do not cross anywhere. End of problem.